How does one actually build an agentic system? It's easy to find bits and pieces of information online, but it can be hard to see the big picture. I'm an AI engineer at Accenture, and I'm going to tell you how to build an agentic system from start to finish, from ideation to production. Whether you come from a coding background or not, you're going to walk away with a better understanding of how to build an agentic system. This is going to be a 6-step process for how to build an agentic system. And the first step is going to be start to finish. What are we going to start with and how are we going to finish? And what do I mean by that? What I mean by that is, where do we start? We can start from an idea or a pain point or an ambitious vision. We can start from any of these things and arrive at a production system. For this exercise, we're going to start with a pain point. I should probably... So what is our pain point here? Let's take a developer workflow. But again, you don't need to have come from a coding background to understand this. Let me have an application. There are tests that make sure that when a new feature is built, that we do not break the rest of the application. And what happens is these tests will fail inevitably. And we have to triage what happened. And this triage process can be very tedious. So let's have an agent do it. And we're talking about a sort of production system that has hundreds of repos, and it is presumably in a environment that mimics production. Are you with me so far? So the pain point is tedious to triage test failures. Want automated triage. Okay, that is the starting line. What is the finish line? The finish line, let's give it a different color, is, let's say we have, 1,000 users. We want to be able to triage within 5 minutes. And we want the diagnosis to be correct at least 70% of the time, which is not very ambitious. And let's shoot for 50% reduction in triage time. So we started with the pain point of tedious to triage test failures. Our idea is to automate the triage process. And our finish line is 1,000 users who will interact with this automated process, get a diagnosis within 5 minutes, and the diagnosis will be correct 70% of the time or more. And we'll see user reported 50% reduction in triage time. So that is the goal. And the second step is assessing whether the goal is good and whether the idea is good. I will explain what I mean. If I can find some white space. What are some common problems that an agentic system can have? In other words, is this an appropriate area for AI? Is it super important that the result is correct? Is the review process going to fall prey to automation bias? Meaning, if a human is reviewing this, are they going to naturally want to not review it carefully? Is it open-ended? And AI can certainly handle open-ended processes, but is the goal well-defined? Is there an end state that we're trying to get to? Is it possible to develop a deterministic process that is sufficient instead of having to rely on AI? So let's answer some of these questions. Is it important? As in, is it too important? If the diagnosis of the test failure is wrong, what happens? If wrong, test fails again. Maybe it's better to call this consequent of being wrong. So if the diagnosis is wrong and the fix is wrong, the test will fail again. Not a huge deal. Will there be automation bias? Maybe a better way to put this is, does the process encourage lazy review? Maybe, but the test will fail and humans should watch for wrong way to make the test. Not any more than regular PR review. Okay. Is the goal well defined? See finish line, or scope. See scope. Can a deterministic process handle it? not without a tremendous amount of work, right? To account for every possible variation of what can go wrong in a test and what the log will print, etc. So it does call for a language processing model that can adapt to a variety of situations. Step 3 is simplest thing you can build, i.e. prototype. So we have a user and we have an production simulation environment, or we can just refer to it as dev instance. And we have the LLM, and maybe we have some sort of mechanism to trigger the LLM call, which will be listening or paying attention to the tests that fail. And it will call the LLM. What will it give the LLM? Logs. What will we get back? Diagnosis. The user can create a PR, and there we have it. Prototype done. This is why people say demo is easy, production is hard. Coming up with a prototype is extremely easy, right? Because you're focused on the main idea, which is to give logs to the LLM, get the diagnosis back. Another way to think about it is inputs and outputs. Input is logs, outputs is diagnosis. Right? That's our system. That's what we're trying to build. And you want some way to show the user what happened. And this can be also a PR. So maybe these are intermediary input and output, and the final or end-to-end input is a PR, output is a PR. And in case you don't know what a PR is, it's a set of code changes for someone to review. Step 4, create a big mess. So you've drawn this prototype. Now let's start to make it messy. What happens here? Interrogate. Step 4, interrogate and enhance. So red text is making me nervous. Okay, here's our prototype. And what is going on here? What do you mean give the LLM logs? Where is this LLM? This LLM is in Bedrock. Let's say they're in AWS Bedrock, which houses AI models. So if you think about your local Claude, it is housed by Anthropic. In a production system, your Claude will likely be housed by AWS, Azure, or Google. And the way you send these logs is an API call to Bedrock, so specifying how we communicate with Bedrock. But you can interrogate this prototype from several angles, but the easiest way is grab your finish line requirements. So let's zoom out just a bit here. Okay, we have 1,000 users. So let's make more users. And each user is going to have their own simulation environment, just for good measure. So it starts to look like this. So everyone's calling Bedrock and getting back diagnosis. And right now, the LLM has logs. And that is all it has because we gave it to the LLM, right? And while you can deduce a lot from the logs only, you may want to know other things like the code. Let's do that. So let's give the LLM access to the code base. Maybe Git, Bitbucket, and maybe documentation. These are tools that an LLM can use. What are these arrows? How is it doing this? Well, it's probably a database containing some documentation. This one, you can imagine API calls to Bitbucket or Git. You do a query to the database. You can hear the term RAG used for this particular database of documentation, which may also contain the code base. For our purposes, let's keep them separate. API call, and it returns parts and lines of code. All for the purposes of informing me, all right? But can you do this? Can say the LLM wants to call the database. What does it actually do? Instead of returning a diagnosis, it will say, can I call the database. And what can the test listener do to oblige the LLM? It cannot. So what do we need? We need a middleman who can fulfill this request of, can I call the database? All right, so let's create a middleman. Give ourselves some more room. It's typically called a server or serverless, which is server that spins up on demand. So you can either have a dedicated server or computer that can make calls to the database, retrieve documents, and pass it back to the LLM. Or you can have someone like AWS spin up a server on demand, and once it fulfills these requests, take it back down. Why? Because it costs less. It costs a lot less. So let's fix these arrows. So tool call layer is really here, but I don't even need to show it. I will combine codebase into this rag. For the way, this right here is an agent. This over here is an LLM. This is an agent. I get that. That's good enough. So an agent is an LLM that has a server to call databases. Doesn't have to be a database. It can do other things. But essentially, these processes together are considered an agent. So when you talk to an agent, you talk to a server, and the server talks back. After talking to the LLM, grabbing data from database, after it does all of that, it talks back to you. Right? So now we've got a proper agent, and sometimes you'll hear it referred to as the agent loop. So you have an agent loop here. You have a number of users. We got other requirements like diagnosis under 5 minutes, correctness over 70%. But let's deal with those 1,000 users a little bit better. So when you have a computer and you have 1,000 people who want to use this computer, sounds kind of bad. It's going to make the computer freeze. So what do? We want to have them line up. Let's line them up, single file, in a queue. And we'll worry about the return calls later. Send logs, send logs, send logs. We have a queue now. And something is going to read from this queue. The computer itself can go get it every so often. Or as soon as there's something in the queue, another nifty little process, another middleman, can take it and give it to the server. And there are ways for the server to pull from the queue. Okay, now, how's the user going to get a PR? How are they going to see the diagnosis? How are they going to get the PR? Well, the arrow we had earlier, going from the server back to the listener, it's not quite correct, right? You don't tell this guy what happened. You're probably just going to go straight to Git or Bitbucket and using an API, create a PR, right? Or actually, let's keep it simple. Let's create a comment on a PR with diagnosis. The user just knows, because maybe they can even tag the user. Let's make that clear. The users have access to Bitbucket. Whoa, okay. All he's going to say, read diagnosis. Okay. This is a bit beyond prototype now. We have many users. How are we going to diagnose in under 5 minutes? Well, for starters, let's just say you don't have to be that thorough to hit 70% correctness. So let's limit the time we spend in this agent brain area by saying you only get 2 tool calls. And we can guess that with 2 tool calls max, the time spent calling the database a couple of times is going to fall roughly under 5 minutes. Okay, now correctness of over 70%. How do we even know what percentage of diagnoses are correct? How do we know that one diagnosis that it makes is correct? Where does it say that? It probably needs to make the fix, right? So on top of diagnosis, plus another PR with fix. We can make the creation of the PR trigger a rerun of the tests, we have a loop. Once again, when tests fail, it's going to trigger the API call to send logs. Actually, this is no longer an API call. It's just send logs to the queue. Server will pick it up. And how do we know that these same tests that we fixed have failed? We need to know which test is which, right? All right, we need another database of logs and individual tests. Maybe which PR, which test, pass, fail, right? And it needs to have that kind of information. And this needs to be available to the server. And in fact, you can point this way or this way. Probably better to point it here so that we always ingest whatever is happening. Keep this separate from the triage, right? So agent does the triage. Before the triage happens, everything that happened has been cataloged. Right? Okay, now we have ingestion. So I do this. Okay, ingestion process. We have the agent. We have a feedback process here. Triage. Okay, ingestion, feedback, triage. Let me zoom out so you can see everything. All right, so we know which ones are correct. So we can measure the correctness. Now, in order to claim 70%, you need to observe. You need to keep a ledger of how many times the diagnosis was correct. We need another database that observes correct diagnosis rate. And this server needs to provide that, right? Okay, diagnosis, correctness, 50% reduction in triage time. It has to be user reported. We'll do some kind of survey, and here we have it. We have interrogated and enhanced the prototype to this big mess of ingestion, triage, feedback, observability. Sweet. Now, in reality, you're going to interrogate and enhance much more than this and arrive at something along these lines where every part is interrogated and accounted for. Don't have to go through every single one of these right now, but you can think about frequently asked questions and how you're going to handle how many times you call the database using something like a cache. The main thing you may want to interrogate is the agentic loop itself. Now, I'm not going to go into the details of this particular loop, but you can imagine there's a lot of nuance to how this communication between the LLM and the server happens. What information do we track? Do we track exactly the full messages that the LLM gave the server? Okay. Step 5, next level stuff. So let's go back to our enhanced mess. What would it look like if we were to take this up a notch, go to the next level, make it really incredibly agentic? Maybe what this thing can do is come up with a set of hypotheses, test the hypotheses, / gather evidence or counter evidence, choose the best diagnosis, and maybe this can drive the correctness to 90%. So essentially, we're trying to better the system with greater ambition and see if we can make that happen and what it would take to make that happen. And that's where this portion within the pink box, the agentic loop, needs to be engineered better, right? Because that's where the thinking happens. The LLM, depending on how effectively it calls this database, how effectively it manages these logs, is going to determine how good of a diagnosis it gives, right? And we may need to track understanding across multiple calls and to the database, right? So it will say, hey, what's going on in this part of the code? And that will either serve as evidence or counter evidence for certain hypotheses. And most likely, it will need more information and it will need to remember what it just learned, right? Just like our local Claude Code memory system. You need a memory system, some sort of memory, which can be chat memory, which can be understanding of code, understanding of failure, And throughout this process of deduction, all of this need to be managed within this server. And it will need to be passed back and forth between the server and the LLM and get updated, modified, appended with more information. Could be a database, some of it could be in memory. It's a lot that can happen here, right? That's one example of how you make this more ambitious. Step 6, last but not least, you want to evaluate your system. And you want to evaluate here. You want to evaluate it's making stuff up as you can. At what point is it making stuff up? So you can cite citation trail to the document or code. So based on this set of evidence, this is my conclusion and this is my diagnosis. You want to monitor tool calls and make sure it is not going over 2 tool calls. But maybe for this ambitious design, we need to allow 5 tool calls or unlimited tool calls, maybe not, maybe 10 tool calls. And sure, it's not doing anything weird, like grabbing the same document multiple times and going in circles. You want to have a golden set of questions and answers, human labeled. And this is really for model updates, prompt updates, and data updates that can cause unexpected behavior. So by running the set of human labeled questions and ensuring that we get an appropriate set of answers, you know that you did not break the system by updating the model, updating the prompt, or updating data. You can all of these, maybe with the exception of, I'll call it logging tool calls. So all of these would be considered offline evaluations. And you can have online evaluations, meaning day-to-day, the system is in production. What are you watching out for? How do you know your system is behaving as it should? So you can monitor success rates or maybe second run pass rates, right? So if it's been fixed and you run it again, you run the test again, it should pass. And normally it passes, let's say 90% of the time. And if it goes to 80, you're like, what's going on? And email someone to come take a look. If it goes to 95, you're still a little concerned. You might want to email someone to ensure that it's actually just performing well and not an indication of unexpected error in the system. Might be good. And there you have an agentic system. You have considered a lot of aspects and come up with this mess. What are all the components that go into it and what the process is like for designing a production agentic system. Of course, there's a lot more we can discuss here, but I hope this was helpful. It would mean a lot if you subscribe to the channel. Let me know in the comments what you'd like me to explain more in detail. I'll see you next time.